You are running an application on App Engine that utilizes CloudTrace. Your /product-details endpoint fetches information for 4 distinct products by calling /sku-details. You want to optimize this endpoint to decrease its overall latency. What should you do?
Option A. Scale up the App Engine instance class to a larger tier. Option B. Upgrade the underlying storage to use SSD persistent disks. Option C. Modify the /product-details code to execute the SKU requests concurrently. Option D. Migrate the /sku-details data into a database and query it instead of making web service calls.
This scenario focuses on performance optimization in an application that relies on multiple network operations. When an application performs several sequential requests, the total time taken is the sum of each individual operation. By using tools like CloudTrace, developers can identify bottlenecks in how these requests are orchestrated. The challenge is to identify the most efficient strategy to reduce the time the application spends waiting for these external network responses.
In my view, the correct answer is option C. Modifying the code to execute the SKU requests concurrently is the most effective approach. When your application performs 4 separate network calls one after another, it suffers from additive latency. By running these requests in parallel, you allow them to happen simultaneously, effectively reducing the total wait time to roughly the duration of the single longest individual call.
Regarding the other options, scaling up your instance class or upgrading to SSD storage will not help if the primary bottleneck is caused by sequential network wait times. These infrastructure changes do not address the core issue of inefficient call orchestration. As for migrating data to a database, that would introduce unnecessary architectural complexity, which is not required when simply optimizing how the application handles existing network requests.
A quick exam tip for scenarios like this. Always prioritize identifying the logic bottleneck before considering infrastructure scaling. If your trace data shows sequential network calls taking too long, look for ways to parallelize those operations first, as that typically provides the greatest performance gain with the least amount of architectural change.